This video is going to cover multiplying and dividing of rational expressions. So rational expressions means any expression where there is a ratio or a fraction involving variables. And so this first part says multiply and identify any x values for which the expression is undefined. So an expression is undefined. So in these cases, an expression is undefined if some value of x makes the denominator equal 0, because we can't divide by 0. So we'll start actually by stating when the expression is undefined. And it would be undefined if x minus 3 equals 0, so x equals 3, or if 3x minus 2 equals 0, which would come out to x equals 2/3. Right? And really, these are both inequalities, or not equal signs. So this expression, we're not allowed to have values of 3, and we're not allowed to have x values of 2/3. All right, now that that's out of the way, let's get down to multiplying these. These are fractions, and to multiply fractions, we just go straight across. So this would come out to x plus 1 times x divided by x minus 3 times 3x minus 2. And there's no simplifying we can do here, so we're going to expand to both parts. So here we can distribute x, and we get x squared plus x divided by, and the denominator we can multiply with the FOIL method, so let's put it over here. So that's going to be 3x squared minus 2x minus 9x and plus 6. And combining like terms gives us 3x squared minus 11x plus 6. So that's how we multiply rational expressions. So this one, first, let's start with where the expression is defined. So we can see we have x plus 5 and x plus 2 in the denominator. So x cannot equal negative 5, and x cannot equal negative 2. That's because each of those values would make the denominator equal 0. Now, to multiply these, what actually makes multiplying easier is if we factor everything out first. Because sometimes we can factor, and then we'll find out that there's common factors in the numerator and denominator that we can simplify out. So let's factor x squared plus 3x plus 2. So we need numbers that multiply to make 2 and add to make 3, and that would be positive 2 and positive 1. So step 1 whenever you're multiplying is factor everything. And you'll see why here in a second. So we have x plus 2 times x plus 1 over x plus 5 multiplied by x minus 3 over x plus 2. So multiplying again, that just means we go straight across. So this now comes to, we're not going to expand anything just yet. So x plus 2 times x plus 1 times x minus 3 divided by x plus 5 times x plus 2. And the reason we didn't want to expand is we can see, so now this entire thing, this entire numerator, is all things that are multiplied together, right? So because the entire numerator is things that are multiplied and the entire denominator are things that are multiplied, we can actually cancel out the factor x plus 2 since it's common to the numerator and denominator. One way to help visualize this is we can kind of separate this. So this is x plus 2 over x plus 2, and then multiplied by the rest of it. So x plus 1 and x minus 3, which I can't fit, and x plus 5. So you can see this portion here on the left clearly divides to 1, right? Because we have the same number divided by itself. And that's because the whole factor is the same, not just a part of it, right? So usually we just, from here, since everything's multiplied, this part divides to 1. And I will make you specify what cancel out means when you say it. It divides to 1. And then we get, so the remaining part is x plus 1 times x minus 3 divided by x plus 5. And then here we'll go ahead and expand the numerator. And this would come out to x squared minus 3x plus x and minus 3 which then is x squared minus 2x minus 3 all over x plus 5. One thing that is a very common mistake that I will address here is this idea that if you have something that's the same in the numerator and denominator, it can always be canceled out. It can be canceled out up here because everything is multiplying and dividing, or everything is being multiplied. We have no addition or subtraction. We have a binomial times another binomial times another binomial. In the numerator, or in the final simplified form, these are all being subtracted. There's no multiplication of parts. So what we can't do is this, right? Because that defeats the order of operations, right? The entire numerator is really a set of parentheses that we would have to work out first before we could start simplifying. All right, so that does not work. We cannot simplify there. So this is your answer. It cannot be further simplified. So moving on to dividing. So remember, when you divide fractions, one thing I used to hear a lot is keep, change, flip, and I hated it because no one ever told me what it meant, and it strips out the actual vocabulary of what you're doing. So when you divide fractions, you multiply by the reciprocal. All right? So what that means is we take the second fraction and we invert it. We make the denominator the numerator and vice versa. So this division expression is equivalent to 5 over x minus 3 times x squared minus 6x plus 9 over x plus 1. And now we're multiplying fractions, or now we're multiplying rational expressions, which is exactly what we just did. So theoretically, I could stop teaching right now, but I won't. That's minus 6x, and that's plus 9. And that's plus 1. So then here we'll follow the same process. We're going to factor out x squared minus 6x plus 9. So we have 5 over x minus 3 times x minus 3 squared, because it's, so we would need a product of 9 and a sum of -6. So that would be -3 and -3, and over x plus 1. And from here you can see this factor of x minus 3 appears twice in the numerator and only once in the denominator. So even from here we could just go ahead and start simplifying. So the step of writing it all under one, or all as one fraction, can actually be ignored. So this squared part is going to cancel out with the whole factor x minus 3, and we'll be left with 5 times x minus 3 over x plus 1, or 5x minus 15 over x plus 1. And again, from here, if you tried to cancel these x's out, a poor little kitten would die a tragic death. So don't do it, right? This is parentheses. This is parentheses. Order of operations. You know the drill. All right, so this last one. This one looks absolutely horrible, right? We've got fractions on fractions on fractions. But remember, this thing, this middle bar, is really just a big old division sign, right? So we can split this up. Let's make it that part divided by that part. Make our lives look a little bit less intimidating. So we have x squared minus 9x plus 20 over x plus 6 divided by x squared minus 11x plus 28 over x squared plus 7x plus 6. All right, and then, so now we've reduced it to a problem just like the last one. So again, theoretically, I could stop now, but I won't. So now, again, dividing fractions means multiplied by the reciprocal. So x squared minus 9x plus 20 over x plus 6 times 7x plus 6 over x squared minus 11x plus 28. And now, again, we reduced it to, first we reduced it to a problem like 3, and now we have it as a problem like number 2. So we just need to factor everything. And there's 3 things that we need to factor. So x squared minus 9x plus 20. We need numbers that multiply to positive 20 and add to negative 9. And that's going to be negative 5 and negative 4. Numbers that multiply to 6 and add to 7. That's x plus 6 and x plus 1. And numbers that multiply to 28 and add to negative 11. And that is x minus 7 and x minus 4. And then from here, we can go ahead and start seeing our common factors. We can, because remember, this whole thing is now just one big fraction, and everything is multiplied. So we have a common factor of x minus 4 and a common factor of x plus 6. So what's left after we divide our common factors to 1 is a factor of x minus 5 in the numerator and an x plus 1. So we have x minus 5 times x plus 1, all divided by x minus 7. And here we can expand this part, and we'll get x squared minus 5x plus x minus 4x minus 5 all over x minus 7. All right, stay tuned for the next video on adding and subtracting rational expressions.